What do you do if you have a part of your application that requires some extra data that lives in a different application and you need to perform expensive queries, filtering, sorting? What do you do if keeping the data in that other application is too slow? Well, you can replicate the data into your application, and today I'm going to be talking about some of the practicalities of getting that to work. So what does this look like? Well, for starters, you have an owning application and it owns the object. You have some form of data transfer, usually over a network, and then you have a copy of the data in the other application. And the point here is that there's only one single source of truth, and that's in the original application, but that you have a copy that you can refer to and optimize in your subscribing application. So how does this look when it's working? First, the user creates the object in the owning system, then that system will create a notification which is sent to and is processed by the subscribing system. Later, the user updates a referring object so that it is now pointing to the copy. At some point, the first user might change the original and an update sent to the subscribing application. At some point, the first user might delete the object from the originating system, at which point it will be deleted from the subscribing system. So there are some things that will almost reliably go wrong. The first is that messages can be delayed or fail to process, arrive out of order, or in some cases, if there are errors, they might need to be retried. In some cases, they might even arrive twice. The second source of errors is when you're trying to process the update messages, and that can happen if there are programming errors, and this will happen as you're creating the handler. That's partly because programmers make mistakes and people are fallible. The other reasons why this might happen is if you put validation into your destination system, and I'm going to recommend that you don't. The third place that errors might occur is in the data store, and that's when you have constraints in the data store that prevent you from writing or changing the records as you are processing the messages. One of the reasons why this might happen is a foreign key constraint to one of the objects that only exist in the destination system. And the fourth and final place where things might go wrong is in a third system, like a client where you're rendering data from both places, and that third system may not be aware of the nuances of message processing and timing, and it might be presented with an incoherent view of the data. Okay, so how do we solve out of order delivery? A good first start is to have a version number on each of the records that you publish, and if that is a strictly increasing version number, that means that you can disregard messages that are stale. For failed delivery, well, the best thing you can do is create a resend mechanism, and that means that you don't have to necessarily deal with the message correctly on the first time, and particularly if you've got a human in the loop, then you might be able to re-trigger it to send. One of the most important things is when you're doing deletes that you make a soft delete, and that gives you an opportunity to capture the version number, which is important because if you have an update arrive after the delete, otherwise you might not know what to do with that. Would you reinstate the record, perhaps, or what does that mean if a create and an update arrive out of order? So having soft deletes means that you can tell that the record should no longer be active. So Programming errors are inevitable and you should expect these. I talked about resending the message before. The other option is allowing the same version of a particular record or a particular notification to be processed twice, and that will allow the developer to change and fix their code, and then you can rerun the message. And one thing that I'm going to recommend, and this isn't mandatory, but I think that if you avoid transforming the data, you have a really good chance of not creating shapes of data that aren't compatible with the two different systems. So solving this third problem basically uses some of the same things that you have already had to build for the other problems, but the things that are good for this, the things that solve this problem are soft deletes, keeping the model data verbatim, and avoiding validation. These things prevent data that's valid in the source system from not being stored correctly in the destination system. Problem number 4 is timing, basically. And the way to solve this is to build the system to tolerate and temporary inconsistency. Okay, you've got a replicated object and it's been running for a month, 6 months, a year, and now you've decided that you need to add extra fields to that record. Perhaps they were in the original object to begin with and you never brought them across because you didn't need them. Perhaps they are new fields that you need to add to the source system and the destination system. Perhaps you just made a mistake. Perhaps you're building this for the first time on an object that already exists and there's already data in the source system. Well, there are a couple of things that you're going to have to do, and you're going to have to do them in the right order. First of all, you're going to build the place to put the new field, and you'll put that in the destination system. Then you'll build the handler for that new field and start to populate it, and then you'll start sending the messages from the source system. Finally, you can run a bulk update from the source system to the destination system, and that will backfill all of the data that you have missed to date. So job done, right? But not so fast. I think that you should expect this to break sometimes. And what do you do about that? Well, first of all, you want to be able to detect when breakages have occurred, and also you want to have a mechanism for dealing with that. We talked about triggering retries. That's a really good way to do that. And what you will need is to determine which of those records you need to retry, or when you need to redo the bulk load. So you need a query that checks for the fields and objects in both the source and the destination system and check that they are equivalent. And you need somebody looking at the messaging. I think that you want to build or use something that will give you visibility of when the errors occur. So summing up, we've got a source system which owns an object. We have a destination system that wants to use the object and needs it locally so that it can perform otherwise expensive queries, such as searching and filtering on the two objects, which, if you had those in two different systems and you had to try and filter and sort them together, and these tables are really large, then actually that is unrealistic. So the reason you want to do this is so that you can make your queries efficient. But you really only want a single source of truth. And how do you do that? Well, this is how you do that. Thanks for watching. I'd really like some feedback, so you can hit me up on Twitter, on Threads, follow my GitHub, send me an email, or just like and comment below, and I'll talk to you next time.